Hello, I'm Seth Daly with the University of New Mexico College of Pharmacy in the Department of Pharmaceutical Sciences. This is a video in our Calculation Success module, and this video is a skills video, and we'll be talking about general math and algebra. So the first thing I want to talk about in this video is significant figures, or sig figs. So sig figs have to do with precision, and we only want to carry forward the lowest precision number, okay? And so in this example, we are multiplying 3.1 times 4.25, okay? Now 3.1 has two significant figures, and 4.25 has three, okay? So when we get to our answer, we're only going to use two sig figs, okay? Even though if we do that math, the answer is 3.1 times 4.25, 13.175. Because of sig figs, we're only using 13. So sig figs are important, but we're not going to use them for the NAPLEX, okay? So I just wanted to explain them, but the NAPLEX is a bit different, okay? So we're not rounding until the very end step, okay? And that's why it's important in that introduction video when I said make sure your calculator has an answer key or a way to store data. So we're keeping the decimals in our calculator. So if we had used that top equation, we would keep this in our calculator and keep working through until our final answer, and then we would round how the NAPLEX says to. So how do we round? Well, the CKAs, the Calculations Key Assessments that are part of my course that you'll take every spring and fall, will tell you where to round, and so will the NAPLEX. Now, they'll do that in one of two ways. They'll either tell you to round to the tenths, hundredths, or thousands, and that's the same thing as saying 1 decimal for tenths, 2 decimals for hundredths, or 3 decimals for thousands. So let's practice this using pi. So pi is 3.141592653. So if we want to round to 1 decimal, that's the tenths, I'm going to copy down to the tenths and one more, okay? So we're going to round to here. We're going to look to the next number. If the number is greater than or equal to 5, we round up. If the number is less than 5, we round down, okay? So we look to the right, it's a 4, so we're going to stay where we are and we're going to round down, and our answer is 3.1. For the next one, let's round to 2 decimals. So I'm going to go out to the second decimal and write one more number, okay? So we're rounding here, we look to the right, still less than 5, so we're going to keep that number that we had. We're rounding down to 3.14, okay? Now, if we go to 3 decimals, 3.141, and we write the next number, okay, we're rounding to this place, we check to the right, and it's at 5. So at this point, we're going to round up. So this becomes 3.142, okay? So let's practice that with new numbers. So let's round this centimeters to 2 decimals, okay? So I'm going to look to the second decimal. I'm going to go over 1. It's greater than 5, so we're going to round this to 5.55 centimeters, okay? Let's round this one to the hundredths. Remember, the hundredths is the second place, so it's just like rounding to 2 decimals. So we're going to round to that point. We look 1 to the right, it's less than 5 this time, so we're going to keep the number the same. All right, last one, we're rounding to the thousandths. So we go out to the thousandths place, or 3 decimals. This is 2. Oops. This is why you have a handy dandy eraser. The hundredths is 2 decimal places, and remember 2 decimal places is also hundredths. Okay? So we're at the thousands, we're going to look 1 to the right, we're less than 5, so we're going to round down and keep it as 0.004, okay? So you can practice these again using just the blank presentation, but that's how you would work through it. Now, unfortunately, there are rule breakers, and sometimes rounding, we don't always round with that greater than or equal to 5. And some of those examples I'm going to give you here. So for doses, if you are solving for the number of doses or the number of tablets, we always round down. Now, why is that? Well, we can't give a fractional dose or a tablet. So if you get to the end of the answer and it says 1.5 tablets, and it asks you how many tablets you can make, we can only make one tablet, because we would never prepare 0.5 of a tablet and give that to a patient as a dose. That's not a dose. That's not a tablet. Okay? So we always round down, even though that says 1.5. Okay? So let's try this example. How many 325 milligram tablets can be prepared from 2,000 milligrams of API? So I want to know how many tablets, okay? And you guys will notice I'm underlining the knowns and I'm circling what I'm looking for, okay? So here we're going to do ratio. So if it's 325 milligrams per tablet, how many tablets can I make from 2,000 milligrams, okay? So I set up a ratio and a proportion. So the ratio for this side is 325 milligrams per tab, and the ratio for this side is 2,000 milligrams for unknown tabs, right? And we make sure that tabs are on the same side and milligrams are on the same side. Now we're going to cross multiply, okay? So 325 milligrams times X tabs equals 2,000 milligrams times 1 tab. All right, remember, when we write this as tab, we're assuming there's a number 1 here, okay? So we just carry it forward. Well, now we want to solve for tabs, so we're going to divide both sides by 325 milligrams. This cancels, and here our units cancel, and we're left with tabs. So when we solve, 2,000 times 1 divided by 325 equals 6.1538, and there's more decimals in my calculator, and I'm just keeping them there, tabs. But it says how many tablets can be prepared. We would never prepare this fractional tabs, so our final answer is 6 tabs, okay? And the NAPLEX or my CKA will probably say something like round to a whole number. But when you're doing this functionally in a clinic or in a pharmacy, you would always make this assumption and you would round to 6, right? Because we wouldn't make that fractional tab. Biostats. Biostats is one where it breaks it in the opposite way. So for example, in something like number needed to treat, we always round up, okay? So if we got a number needed to treat that says we need to treat 4.3 patients to see the effect, we can't treat a third of a patient, so we round up to 5, okay? So biostats, we're going to round up for that number needed to treat, okay? Does that make sense? So if we need to treat 4.3 patients, the only way we can do that is by treating 5 to see that effect, because we can't treat just a third of a patient. So this is another one where it breaks the rule, and it breaks it in the opposite way as this doses one. So you'll just understand and find these rules as you move through pharmacy. But if you're just doing math for the NAPLEX, we're always going to follow these rules, okay? So 1, 2, or 3 decimals, and we're going to use the greater than or equal to 5. All right. So in one of those examples, I did some general algebra manipulation. So let's practice that here. So in this first example, we have x plus y equals z. Well, what if we want to solve for y, okay? And so we're going to take that equation, x plus y equals z. We want to solve for y, so we need to get rid of that pesky x. So we're going to subtract x from this side and subtract x from this side. So we've done it from both sides so that the equation is still equal. And x minus x is 0, so we get y equals 2 minus, or sorry, z minus x. Okay, so we've solved for y. Let's do the same thing, but when we have a division instead. So here we're solving for z, and unfortunately z is on the bottom of this equation. So we're going to take our equation, okay, and we want to get z on the top side. So let's multiply both sides by z. Okay, so now these z's cancel, and if we rewrite what we just did, we have z times x equals y. okay? But we still want to solve for z. So now we're going to divide both sides by x, okay? These x's cancel, and now we're left with z equals y over x, okay? So this equation is equal to this equation. All we've done is change what the variable we're solving for. And in both cases, we're doing the same things to both sides. In this one, we subtracted from both sides because we have an addition sign here. And down here, we have a multiplication and a division, okay? So we're going to multiply to get the z on top, and then we're going to divide the x to get the z alone, all right? So why do we need to know how to do this? Well, when we're setting up. All right, so why do we need to know how to manipulate algebraic equations? Well, it's an example we'll use here for these ratios. So we have 4/10 equals x over 5. Now we have two ways of doing this. The first way is cross multiplication, which we did in a different problem. And the other method is that algebraic method I just showed you. And I'll show you why it's important to know both kinds. So here, if we just cross multiply, okay, 4 times 5 equals x times 10. We're going to divide both sides by 10 to get that x alone. Okay, the 10's cancel, and we're left with x equals 4 times 5 is 20, divided by 10 is 2. Cool. Now if we do it the algebraic way, 4 divided by 10 equals x over 5. If we just want to get x alone, we can just multiply by 5 on both sides. These 5's cancel, and we're left with x alone. And if you notice, 5 times 4 divided by 10 is the same as what we did over here. 5 times 4 divided by 10. And x equals 2. So they both get you to the same place. One just does it in less steps. Okay? So if you can do all of these, you can tell where it's going to be easier. Okay? So in this example, this will show you why the other method is useful. So here, 4/10 equals 2 over x. Okay? If we cross multiply in this example, we get 4x equals 2 times 10. We solve for x. These cancel, and we get x equals 2 times 10 divided by 4, so x equals 5. If we try and do this one with the algebraic method, it'll work, but you'll see why we would prefer to do cross multiplication. So 2 over x. So we want to get x on top, so we multiply both sides by x. These cancel, so we could rewrite it as x times 4/10 equals 2. But we want x alone, so we're going to multiply both sides by 10. And we're going to divide both sides by 4. Okay? That lets these cancel on this side. And now again, we're left with x equals 2 times 10 divided by 4. But we had to do many more steps to get there to that same answer of 5. So in some ways, this is easier, algebraic, when the x is on top, and that cross multiplication is much easier when x is on the bottom. So you'll kind of get practice with this and learn what's the easiest way to do it. Now all of them work, so if you prefer to cross multiply for everything, go ahead and do that. If you prefer to do the algebraic method for everything, go ahead and do that. But sometimes when you get used to it and you practice these, you'll know that this works better for algebraic and this works better for cross multiplication. All right. Another thing we need to know about general algebra is dividing with fractions. And so in this example, we're going to use the keep, change, flip method, or KCF. It's close to Kentucky Fried Chicken, but not quite. So in this example, we're saying what happens if we take 1 milligram and divide it by 10 milligrams per mil? Okay, well that doesn't work because we have milligrams on the same side. So we can rewrite this. So we're going to keep 1 milligram. We're going to change the division into a multiplication, and we're going to flip this last fraction. So remember, when we write mil, we assume there's a 1. So we can rewrite this as 1 mil over 10 milligrams instead of 10 milligrams over a mil. Now, our milligrams can cancel, and so when we solve for this, 1 times 1 divided by 10, 0.1 mils per milligram. Okay? So that's how we use the keep, change, flip method. All right, the next thing I want to talk about is estimation. So estimation is a very useful check of your math, but it takes practice. So it's really about simplifying the math so you can quick check and see if your answer makes sense. So if your question states 112 milligrams, you can simplify that to 100 milligrams and do your math in your head and see if you're roughly in the right place. If you're having a recipe, you would ask yourself, is my answer roughly half of what I started with? So these are called estimations. So let's try that. How many 12 milligram tablets can be made from 100 milligrams of API? Okay, so 12 is close to 10 milligrams, and we have 100 milligrams, so 100 divided by 10, so milligrams and milligrams, that gives us 10 tabs. That's a quick estimate, right? If you have 514 patients that each require 14 pills, how many pills should you order? We can simplify this to 500 and this to 10. So we can say 500 times 10, we should be about 5,000 pills, okay? So this is just a quick way to estimate the math so that when you do the actual math, you know you should be around 5,000 or near 10 tablets, okay? So estimation is really useful when you get to the end of any answer just to kind of make yourself think, did I do everything right? Does that kind of make sense? Yeah, it does. Okay, cool. Now move on to the next question. The other thing you can ask yourself is, does this answer make sense? It's another useful check, but it also takes practice. So, can you picture a liter in your head? Okay, so a liter is like a Nalgene water bottle. Okay. Can you picture a milliliter? Okay, a milliliter is about the end of your pinky finger. Okay, can you picture a gram? A gram is like a sugar packet. Okay, that's about a gram of sugar on a normal table. And it's about the same powder amount as the end of your pinky finger. So I keep coming back to that pinky finger because it's a useful thing to help us remember. So pinky finger again. So if you make a little pile of material that's about the size of your pinky fingertip, that's about a gram for a lot of powders. Okay? So let's try that. Does it make sense? If you get to the end of an answer and you're looking for an IV drip rate and it says 10,000 liters per minute, does that make sense? 10,000 liters, could you give a patient 10,000 Nalgene water bottles in 1 minute? No, right? That probably doesn't make sense. All right, if you got to the end of a patient's body surface area and got 20 meters squared, remember that's 2 meters by 10 meters. Do you think a body surface area should be 20 square meters? No. So again, no. So these are all just quick ways of in your head to think about, did the answer I get come out to a logical solution? And in a lot of times, all that happens is we've inverted a fraction or we've multiplied instead of divided, and these quick self-checks of estimation and does it make sense will help us make sure that we're getting to the right answer. All right, that concludes this lecture on general algebra, estimation, rounding, and does this answer make sense? I'll post a link to the PowerPoint in the description. Thanks, and good luck in your calculations.